Hi, my name is Syed Mohammad Sadat, and this is for my Algorithms and Data Structure Assignment 1. Ready? Okay, let's get started. I've already downloaded the three data sets, and initially I've defined a simple sorting algorithm, which I'll use later on. I'll explain why. So I initialized the word class at the start, initialize the word constructor. Then it's then I initialize three parameters. One for the frequency, one is an empty set for the neighboring words. This is frequencies for the incrementation of a word if it is repeated. Then a spelling, this is for just the spelling of each word. Then I've defined a get sorted neighbors method. This basically sorts the neighboring word set that will neighboring word set in the lexicon for each of the words. Then I've defined a string representation uh, for each of the words. So it's going to be that word, the number of times it appears in the text file, and then the sorted neighbors list. And defined as frequency function. Add frequency function. This increments the count over here by one each time a word is repeated. Then a add neighbors function, it adds the neighboring word to the words sets. Then over here it sorts the entire lexicon based on alphabetical order. Okay, so for my data structure, for each word in the list, I've defined a few functions. One, the clean word function. This basically goes through each word, removes any numbers, and makes every capital letter lowercase. Then this checks if each word, its neighboring word is uh, if its neighboring word can be assigned to its uh, to the sets of each words. So it checks if they have the same length and if they differ by one character. Then I've also defined I've defined a merge sort algorithm basically, which recursively breaks down each word. Then it breaks down each word. Um, the merge sort algorithm, it basically breaks down the lexicon and then sorts it recursively by first breaking it down using these two functions, then then calling upon the merge function which I've defined here to sort each of the words based on alphabetical order, and then build the entire lexicon. Okay, I'll just start implementing it. Yeah. So over here, I finally defined the build lexicon file. So I've initialized a word dictionary which reads through the file. Then for each word in the file, it cleans the word. Then if the word is already present in the lexicon, then it adds the frequency by one, so increments the frequency by one. Then if it's not present in the lexicon, it adds the word to the lexicon. Then afterwards, I've defined the word list for each of the words in the lexicon. So for each word object, I check if it's a neighboring word. If it is, then it calls upon the add neighbors function to add that word to the the word in the lexicon's empty list. Then I use the write function in Python to write words in another text in the output text file in this order. So it's going to be the word, the frequency, and then the neighbor words list. All right, so let's run it. Uh, uh, refresh. Here's the output file. Here you can see the lexicon, which is sorted. So a word, an implementation, then the neighboring word. Okay, you can see there's 105 rows for that for the S1 file. Okay, so I've also mentioned the execution time of comparison between between the two algorithms that between the two data structures that we were asked to do. Okay, so over here I've defined the skip list data structure, which is used for fast searching and insertion of words in a list. Okay, so over here I've defined it's you, and this is done by defining a class which has a key value, uh, which is a key value which acts as a pointer to another similar word. This enables it to skip over elements in a list. So it stores the word as a, it stores the keyword and the word itself and the level which allows it to skip over elements as it crosses through each level. So we have defined the skip list itself, which maintains a probability of 0.5 and maximum level of 4. So it can at max skip over 4 words, skip over 4 elements in a list. So over here, this generates the random level to maintain a probability of 0.5. So this insert method basically finds the position of the file by searching through the list, then checks if the word already exists. If it does, then it increments the frequency. Otherwise, uh, it updates the pointers. Meanwhile, it skips through the elements, then creates a new node for that word, and then links it across the other words. Then the search all function searches, basically receives the word objects in alphabetically sorted order. And over have defined a build lexicon skip list method, which uses the skip list data structure to sort sort the text files uh, in a lexicographical order, then also increment the count number of times the word appears, and then the sorted neighbor words list as well. So it at first checks if the word already exists, cleans the word, adds it by 1, uh, as the increments the word count by 1 if the word already exists, and then uses the skip list insertion method to insert the word in the lexicon. And yeah, that's pretty much it for the sorting algorithm. And I've used the same input file to uh, to show you how it works. So, yeah, found it. Yep, refresh. Here it is, and it's the same one as the one we had gotten before, 105 rows. And that's it for my assignment. I've given the time skips in the report, how long it takes for the large data sets such as the in.txt file, for the medium data set, and for the small data sets as well. Thank you so much.